Good afternoon, everybody, and good morning to those of you on the West Coast. Welcome to the third webinar in a series of 5 webinars introducing the Roadway Information Dataset Reduced Dataset, too many datasets. My name is Omar Asmadi. I'm with Iowa State University and the Center for Transportation Research and Education. With me this afternoon is Skylar Knickerbocker and Zachary Hans, who are both also with Intrans and Iowa State. Today also we have with us Yusuf Mohammed Shah with Federal Highway. And Yusuf, do you want to go ahead and start us off, please?
Hello everyone. Thank you very much for attending today's webinar on intersection crash reduced dataset. This webinar is part of a project with VHB and CITRI to support the Federal Highways STAC to utilize the SHARP2 Roadway Information Database. I want to thank Omar and his team from Center for Transportation Research and Education at Iowa State University in putting together this webinar. I am Yusuf Mohammed Shah with Federal Highways Office of Safety and Safety R&D. I am the manager of RID Technical Support Task Order, and this is third of 5 webinars that CITRI will be conducting to introduce Federal Highways effort to support safety and other research utilizing SHARP2 safety data. We have previously developed 5 reduced datasets from RID in a separate project. The 5 datasets developed are horizontal curves, lane, divided versus undivided roadways, intersection, and speed limit. These datasets are made available to all registered READ users. In this webinar series, the 5 reduced datasets which will be developed are AADT, intersection width, intersection crash, curve crash, and homogeneous segments. The AADT and intersection width database have already been developed, and we had their webinars on September 27th and December 11th of last year, respectively. And this current webinar is for intersection crash. We will send you the dates for the remaining 2 webinars as and when they are finalized. With that, I will hand over back to Omar.
Thank you, Yusuf. And as Yusuf mentioned, the remaining 2 webinars, one would be on curve crashes, scheduled tentatively for April, and the last one on homogeneous segments is scheduled tentatively for June. We will work with Federal Highway and the STAC to determine a date and send an invite through TRB and VTTI and also the RID user group for people to attend the webinar. Before we get started, I'd like you to fill this poll in terms of your organization, whether you're with Federal Highway, with a state DOT, local agency, consultant, academia, or other. So please go ahead and fill. Oh, now you should be able to see it. So I'll give folks just a few more seconds. It seems everybody's filling it in. Okay, the numbers are not changing, so I'm going to go ahead and end this poll. The next poll I would like to do is to see how many people are actually are participating at your location. I'm assuming the majority are one, but please go ahead and vote. Oh, we have a couple of twos, and we have 1 3, and we have one that is 5 or more. I think that will definitely win. All right, I will. I think we got everybody who's going to participate, so I'm going to end that poll and close those so you will be able to see the slides. As Yusuf said, today's webinar is on intersection crash, reduce data set, and I will go through this quickly because I'm probably the majority of you have been on the previous webinars. We will talk a little bit about the selection of the reduced data sets, the description of the data set and the benefits, the methodology that we followed to develop the data set, attributes and the interpretations, assumptions and considerations, how it's linked with NDS, and also integration within the RID. The bulk of the presentation is going to be given by Skylar Knickerbocker, who was mainly in charge of developing the reduced data set. So Yusuf also mentioned this, but here are a list of the reduced data sets that are available right now through the RID. And when we say available through the RID, that means or assumes that you already are a user of the RID and have purchased a copy of the Roadway Information Database. Any copies that are purchased right now will have all of these 8 reduced data sets or 9 reduced data sets included in them. When Federal Highway approves a new reduced data set, we go ahead and provide that data to all registered RID users. The process we followed was back in fall of 2017 when we did the survey through TRB to assess interest and potential and what researchers are interested in terms of reduced data sets. The idea is to facilitate research for users to use the NDS data and the RID data to answer research questions. So we ended up with basically this list here of 9 reduced data sets, and the intersection crashes actually ranked number 2. So we're making our way through the list of developing these reduced data sets. Yusuf reminded me to bring your attention to the fact that on the bottom left-hand side, I don't know if you can see my marker there. I don't think you can see it, but you can download the presentation file. So that is available. And also when we distribute the reduced data set, we will also provide a link to the webinar, and also the file would be included too. So thanks, Yusuf, for that reminder. So we, Federal Highway selected 5 reduced data sets to develop based on the survey. And I think we're actually in the process of adding additional reduced data sets to complete the list. We completed ADT, intersection width, and intersection crashes. We're working right now on the curve crash summary, which should be completed hopefully by middle of March, and homogeneous segments, which should be completed in April. And then the webinars would follow, 1 month after the completion of the reduced data set. If you have any questions, please go ahead and type them in the chat pod, and we will be able to answer them as we go along, or depending on the question, we might wait until the end to answer those questions. You can visit the website for the SHARP2 RID. The address here is in the bottom. It will give you additional information about the webinars, also additional information about the RID itself, and where you'll also get a feel for the data that is included in the RID. There's a question in terms of what's the criteria for homogeneous segments. Since that one we have not developed yet, we are looking at different options in terms of which criteria we would use, because we have collected a lot of information as part of the RID, and it would not make sense to include all of that to produce homogeneous segments. So we have to look at different criterias. One of the things we were considering is the Highway Safety Manual, and also the process that North Carolina uses, the HSI. HSIS. So we're still looking at those options in terms of what we would use for homogeneous segments to summarize the data that we have. Thank you for the question. So with that, I'm going to hand it to Skylar to take us through the process of developing the reduced data set and go through some examples, and at the end with limitations, and we will answer your questions as they come along the screen here. Skylar?
All right, thanks, Omar. So the intersection crash reduced data set, what we're trying to do here is essentially relate all the crashes that were within the RID and associate them to a single intersection, so users can have this information to identify intersections that are high crash locations and just provide easier access to this information so they don't have to do a lot of the processing on their end. So we associate the state crash data that we were provided from each state DOT. We summarize this information to each intersection. But then on the other end of it, we also associate to each crash what intersection ID is associated with it. So you can either do it from either approach of just viewing the summarized information or actually detecting which crashes are associated with an intersection and doing your analysis that way. As part of this, we also we know that not everybody agrees on what buffer distance or what distance should be used to associate a crash to an intersection. So as part of the development of the intersection crash reduced data set, we provide that ability for users to define their own buffer distance so that they can recreate the statistics on their own. Some of the challenges that are coming up on users if they wanted to develop the intersection crash reduced data set on their own is they have to assume a spatial threshold. So what is a distance that is acceptable to identify that this crash is associated to this intersection? There's also situations where a crash may be located near multiple intersections and trying to define what intersection that crash is associated to. There's multiple years of crash data available for each of the states that users have to process. It's a very labor-intensive process to process all that data since they are maintained independently. And then the structure and information across the different states isn't consistent. So we had to dig into each of the metadata to determine what intersection codes or what fields are used for identifying intersections and the severity of crashes that eliminates the need for users to do that on their end. Some of the benefits of the intersection crash reduced data set is we've defined a buffer distance that we feel is acceptable using 250 feet on divided roadways and 150 feet on undivided roadways. I'll get into some of the more of the details with that later. We also, if users don't like the threshold values that we selected, we did provide an ability for them to define their own buffer distance and recreate these data sets on their own using whatever fixed threshold they would prefer. We identified whether there's any ambiguous crashes. So if a crash is located near multiple intersections, we help facilitate that identification of those issues through the development of the reduced data set. And then probably one of the biggest things is we process and summarize the multiple years of crash data, which reduces the load on end users so that they don't have to process 8 years of data for each of the states. And then also, again, like I mentioned, we went through all the different metadata for each of the states and summarized information and provided the summary details in a consistent form across all of the 6 study sites instead of each state being maintained independently. Here's a rough overview of the methodology. We first identify the crash data that's within the RID. After that, we generated a near table associating the crashes to each of the intersections. From there, we have one of the outputs of the reduced data set, which is a clean near table, which is the table that we would do to provide flexibility. After that, we reduced our own crashes based on the buffer distance we defined, and then we've got the 2 outputs of the summarizing crashes by intersection and then updating the crash data with the nearest intersection information. This reduced data set differs from a lot of the other data sets that we've created so far. The biggest difference is that there's actually no new layers being created from this reduced data set. So with all the other previous 9 reduced data sets that we've created, there's a new layer that actually gets added to the RID with the information that we've processed. With this reduced data set, we're actually just appending information to the existing layers within the RID, those layers being the intersection reduced data set and all the crash data layers that are present for each of the states. So it's just enhancing that information and providing these summaries, because there really wasn't the need for creating an additional layer that you would miss out all the information that's already available within the RID on those existing layers. The final cleaning near tables, those are included in the RID, but they're not actually in the database. Those ones are just CSV files that we generated, which again would just help facilitate the ability for users to define their own thresholds if they would want to use something other than the 250 and 150 foot radiuses that we used. Our methodology was created purely using ArcGIS and Excel. We provide both a step-by-step documentation of the exact steps we use to create the crash reduced data set. So if a user wanted to recreate this on their own, or again, like as I mentioned, if they wanted to recreate it but using a different threshold, they could do that by following that step-by-step documentation. In addition, we provide a user guide, which is a basic overview of the methodology that we're discussing today, and then providing some of the more details about the attributes and assumptions that we'll also be discussing today, but in a single guide that you can read through. To develop the reduced data set, we used 3 primary layers. The first one being the intersection reduced data set. This is a cleaned intersection data set that only contains 1 point per intersection. This differs from the route intersection that we use, or that was collected through the mobile data collection, where the route intersection can have multiple points, especially whenever there's multiple routes approaching the intersection. We use all the crash data that was available within each of the RIDs. And then finally, we use the route intersection just to classify whether an intersection is divided or undivided. I'll start going through the first step of identifying crashes data in the RID. Again, as I mentioned, there's typically 1 layer for each year of crash data within each of the states. And I think 5 of the 6 states, the data is available from 2006 to 2013. The exception being Florida has data from 2005 to 2012. We have a summary of each of the different layers that are present for each of the states. Florida and Washington are the only exceptions where they actually have 2 layers for each year of data, which ends up being 16 layers that we end up having to process. They separate it based on whether it's on the state system or off the state system. So a few extra steps to do whenever we're processing the Florida and Washington data. And then all the information that we're focusing on is at the crash level, so we don't get down into the vehicle or the person level, which some of that data is available in both Florida and Washington. In Washington, we end up eliminating and just creating 1 crash point because the data that was delivered in Washington is at the vehicle level. There's a lot of inconsistencies in the data across the multiple states, so they all have their way of coding the data. So we had to go through all the metadata for each state to identify what the coded values were for intersection, the severity, and then the injury types. We tried to standardize it across all the different states so that a fatality is the same coded value, because in some states, if they're going by the Capco scale, a fatality or a K is coded as a 1 versus another state and it may code it as a 5. So we tried to provide consistency across all the states. So whether you're working with Florida data or Washington data in the RID, the values are all the same, and you're looking at the same type of information across all 6 states. The buffer distance was one thing that we spent a little bit of time to try to figure out what was an appropriate distance. Again, there's a lot of different opinions. If we did a literature review looking at how different states handle what distance they use to associate a crash to an intersection, and it varies a lot based on some states will use what type of roadway there are. They'll use where it's located, so whether it's in an urban or rural location. And some states only look in the upstream direction. So there was a lot of variance of how the different states were using it. We ultimately decided on the 250-foot distance on divided roadways and 150-foot distance on undivided roadways because it fit well in line with a lot of what other states were doing and was most appropriate in the data that we were analyzing, and felt like it would satisfy a majority of the users to use it that way. Moving into the next step of generating the near table, this was the process that we did of relating crashes to the intersection reduced data set. To do this, we wanted we had in mind of having the flexibility of users to define their own threshold. So because of that, we decided that a 500-foot distance was probably the maximum any user would use to associate a crash to an intersection. So whenever we developed this table, we used that 500-foot buffer distance to associate any crashes to an intersection within 500 feet. This resulted in a many-to-many relationship. So one intersection can be related to many crashes, and one crash could be related to many intersections. Doing it this way provided that flexibility, as I mentioned, that users could define their own threshold moving forward using that clean near table. Whenever we did this, we processed each year independently. So whenever you've got 8 years of data, we would process each year individually, so repeating the process 8 times. And then in the case of Florida and Washington, having to process it 16 times because of the on and off system.
Scala, there's a question about what if the crashes are within the threshold distance but identified by police as non-intersection related?
Yep. Well, I'll probably just hold off that question until we kind of start getting into the attributes, because we will address that whenever we get into the data. So going through our methodology, then moving into how we reduce the crashes based on the buffer distance. So as I mentioned, whenever we were generating that table, we used that 500-foot buffer distance because we wanted to capture what we thought would be the maximum distance any user would want to define. But to actually develop some sort of reduced data set, we needed to define some sort of threshold. And based on that literature review, as I mentioned, we decided on that 250 feet based on whether it was on a divided roadway and 150 feet on an undivided roadway. The biggest reason that we ended up choosing a different value on the undivided roadway was whenever we started looking into the crash data, we started noticing, especially in the urban areas, you would have situations such as this where one intersection would have a 250-foot distance, and it would start getting the intersections that are associated to a nearby intersection. So to eliminate associating crashes from another intersection to that intersection, we decided to just use 150-foot distance on those undivided roadways. To identify whether an intersection was divided or undivided, we used a similar methodology as what we had done for the AADT reduced data set. So if you remember back to the AADT reduced data set, we used the route name to identify whether it was an undivided or divided roadway. So based on the naming convention of the route name for each route, we're able to identify whether that route is divided or undivided. Based on that classification, we would know all the routes that are entering an intersection, and because of that, we know whether those routes are divided or undivided. We always went to, if there was both a divided and an undivided approaching the same intersection, we would classify it as I don't want to say the most severe, but the highest level, which would be the divided. So if all of the routes approaching an intersection were undivided, the intersection would be classified as undivided. If any of the routes were classified as divided, then we would call the intersection as a divided intersection. Now we start getting into the first actual output of the reduced data set. So this is where we're summarizing the crashes based on the intersection. So to do this, we started summarizing all the crashes as part of this reduced data set. So we're using that metadata that we use to standardize the information. And for each intersection, we would identify how many intersection-related crashes there were. So these are the number of crashes that were coded as a police officer or whoever's submitting the crash report as that these were intersection-related. We included the highest severity crash that there occurred on the roadway, the total number of injuries, fatalities, and then the number of severe, minor, and possible injuries. One of the issues that we come up with is ambiguous crashes. So we also provide a statistic of the number of ambiguous crashes for each of the intersections. In this example below, we've got 2 crashes here represented as the green stars, and then the red dots representing the crashes that are nearby to these intersections. So you can see for the intersection number 1 to the right, it's got 2 crashes associated to it, so it's those 2 crashes that I'm pointing to fall within that 150-foot distance from this crash, whereas intersection number 2 has 3 total crashes, the 3 red dots that are on the map. Because the 2 crashes here are associated to both of the intersections, we identify those as ambiguous crashes. So this is kind of a quality check that we've implemented, that if there's a high number of ambiguous crashes, you may be actually picking up crashes that are nearby. Using the spatial selection, there's no way for us to identify which crash it's actually associated to without actually visually inspecting it, because if we went based on the distance, in this case, this crash is actually closer to intersection number 1 rather than intersection number 2. But whenever we actually start looking at the network, we can see that it is more appropriately would be associated to number 2 based on the alignment of the roadway.
And hopefully, Yusuf, that answers your question in terms of which intersection do you assign the crash if intersections are within the buffer. So there, Scholar will address that further in the constraints and limitations of the data set.
Yep.
And it's also described in the documentation.
Yep. So once we had all this information summarized per each intersection ID, we again processed each year independently and using a pivot table in Excel to get the total number of crashes per intersection ID, the total number of ambiguous crashes, intersections, and then all the different severities. So we would have this information summarized by year. After that, we would then take that annual summary and summarize it for all the years, so you actually get a total number of counts for all the 8 years of crash data we have, and then individual counts for each year, as well as all the other attributes that we were collecting along the way. Once we had this final output, we then join that summarized information to the intersection reduced data set. So as I mentioned earlier, it doesn't alter the existing data that was present in the intersection reduced data set. So in this example, you can see everything that was in the intersection reduced data set is still there. We've just joined the other additional attributes that we collected, which summarizes the crash data for that corresponding intersection and provides those statistics. So this is how you would see it within the RID. Now I'll start getting into where we started updating the crash data with the nearest intersection. So this is taking the opposite approach, where now we're associating what intersections are corresponding to each crash. So we would associate 2 intersections to each of the crashes again. So using that same example that I showed previously, this crash would have intersection number 1 and intersection number 2 associated to it. This allows you to identify whether a crash is nearby multiple intersections, and we would rank those the intersections based on the distance from the crash, since that's the only thing we had currently to rank whether a crash is associated to an intersection or not. And again, we were processing each year independently for each of the layers. Once we've ranked it based on the top intersection or the nearest intersections. We again summarized this information and joined it to the existing crash data. So again, the crash data stays the same. We didn't alter this in any form. We just joined the primary intersection ID, so what that nearest intersection ID, as well as the secondary intersection ID. Along with that, we added what the control type is and the distance, as well as what angle it is to the intersection. This was helped to hopefully be able to, if a user wants to dig into it more, identify whether the where the crash is in relation to the intersection. From there, we go into the final output of the crash reduced data set, or the intersection crash reduced data set. So we took that original near table that we had developed, which is associating all the crashes that are within 500 feet to enter any intersection. The output of that typically includes a lot of fields, so we tried to simplify that for users, knowing that they could always pull that information in later. So what we end up resulting is one CSV file that has the intersection ID that the crash is associated to, the element ID, which is the unique ID for the crash, and then the near distance, near rank, and near angle. Again, all attributes that could be used to define a threshold for users to use instead of the 250 and 150 foot distances that we use. We end up producing one CSV file that a user could use for each of the crash data layers. So there will be 8 for most of the states, with the exception of Florida and Washington, which would have 16 CSV files for each of those. So now I'll get into the attributes that are summarized for each of the 3 outputs. Again, as I mentioned earlier, no new layers are created. So I'll just be talking about the additional fields that we're appending or joining to the layers in the RID. So in that case, for output number 1, we're just appending or joining to the intersection reduced dataset layer. For output number 2, we're just appending or joining to the any of the crash data layers that are present within the RID. And then for output number 3, it's just a CSV file that we're creating. For output number 1, which is what we're joining to the intersection reduced data set, we provide a count total. So this is the total number of crashes within our designated buffer distance of 250 feet or 150 feet. The count intersection, which is the number of crashes that are within that distance that were coded as intersection related. So that kind of gets to the question that we had earlier of the whether the intersections were coded as intersection, or whether the crashes were coded as intersection related by an officer. And this value is a subset of that total count. The count ambiguity, which is the number of crashes that we had identified as being out ambiguous, and then the total counts for each of the years that were present. Then we got into the max severity. So the maximum severity crash in any of the years, we standardize the coding values that we use across all the states so that they're consistent. We included the total number of injuries for any severity levels, and then the number of fatalities, severities, minor, and possible injuries for all years. Now looking at the crash data layers, we would join these features to the existing crash data. The first 2 that we would join is the primary intersection ID and the secondary intersection ID. The primary intersection ID would be that closest intersection related to the crash. If it's blank, that indicates that no intersections were within the buffer distance to the crash. So you could safely assume that those crashes were not intersection related. This value can be used either with the intersection reduced data set or the route intersection layer to get those additional attributes that are present in both of those features. The secondary intersection ID is the second nearest intersection. So in case where there is ambiguous data or a crash is located to multiple intersections, then we would show this value is being populated. Otherwise, it would be blank. To help users not have to join data to either the route intersection or the route reduced data set. We did provide some basic information such as the control type for both the primary and the secondary intersection, as well as what the distance and angle was for both of those for users to know and understand without having to join any additional information. For the CSV file, it's as I mentioned earlier, we kept it pretty simplified for users, so we only included the intersection ID, which you could pull additional information from either the intersection reduced data set or the route intersection layer. The element ID, which is the unique ID that you can join with the crash data layer, and then the near distance, near rank, and near angle, which can all be used for users to define their own threshold. I'll start getting into some of the assumptions and considerations that we had to make along the way while developing this. The biggest one that we identified when you're trying to confirm the data in GIS is the near table uses a geodesic distance instead of a planar distance. So the geodesic distance takes into account the curvature of the Earth. Whenever you use a select by location within ArcMap, it uses that planar distance, and there's no way to force it to use that geodesic distance. So in this case, I performed a spatial selection using the select by locations of 250 feet. You can see in the crash data that this crash was actually 249.8 feet away, but it wasn't selected because of that difference in the planar distance and the geodesic distance. So it's just something to be mindful of whenever you're trying to verify your results in ArcMap. One of the biggest limitations of the spatial selection that we're using is we don't take into account whether the crashes are on a nearby roadway or on a grade separated roadway. So in this situation, this crash is actually being shown that this intersection is being shown that 3 crashes are associated to it because they fall within that distance of the 250 or 150 feet, even though they are clearly on a separate roadway whenever you bring in the aerial imagery. The spatial distance is really dependent on where they're classifying where we're classifying where that intersection point is. So the intersections were part of the mobile data collection, and they are typically located in one of the corners of the intersection, but they can vary. So in a situation like this, where the intersection is skewed to one side of the intersection over the other, you will start to get crashes that may be closer to a nearby intersection just purely based on the location of the intersection point. The geolocation of the states had improved over time. We know based on earlier years of the data, we weren't getting all of the crashes geolocated, so that's also something to be considerate of whenever you're processing or evaluating the data, that all the states' crash geolocation is being improved over time, and so the actual increase in crashes every year may be actually just be attributed to better crash data. One of the things that we really considered heavily was that the distance or that threshold value of 250 feet versus 150 feet. We contemplated just using 150 feet initially for all roadways. Whenever we started looking at some of the situations though, like where we've got an intersection point within the point within the intersection, the distance typically of 150 feet wouldn't always go through the entire intersection. So in this case, whenever we plotted this out, the 150 feet would only actually go to the stop bar of one of the approaches. So 250 feet was more appropriate in capturing all the approaches based on the imprecision of where that intersection point is located. The classification of intersections also varies. So the RID does include some locations which wouldn't technically be called an intersection by a DOT. So this picture here shows a location which is really just an access point to a community, but isn't coded as an intersection by a police officer or any other responding agencies. So in these types of situations, you will get a lot of crashes associated to this intersection point that we're calling an intersection, but you'll get a low number of coded values because an officer wouldn't consider this or wasn't considering it as intersection related. And again, the ambiguous crashes that I had mentioned earlier, without manually reviewing it and seeing the actual crash on the base map, it's hard to identify which crash it's actually associated to. So that ambiguous value is intended to be more of a quality check for users. So if there's a high number of ambiguous crashes, it's something that you would want to further explore of whether all those crashes are actually associated to that intersection or whether they're being incorrectly assigned to that intersection and would more appropriately be assigned to an additional intersection. The other consideration that we wanted to make out was that the intersection summaries that we joined to the intersection reduced data set included all ambiguous crashes. Whenever we were only, for the crash data, we were only joining the top 2 intersections. So in some situations, there could be 3 or more intersections associated to the same crash point. So if you tried to replicate the results just purely using the crash data, your results may differ a little bit because we are only considering the top 2 locations. How to link with the NDS. To link with the NDS, we need the link IDs to be able to request that data from VTTI. Since both the intersection reduced data set and the crash data layers are integrated within the RID and have a route and from and to measure, we can simply use a dynamic segmentation between either of those layers with the links layer to return what links those intersections or crashes are occurring on, and then we can use those link IDs to request the data from VTTI. So a similar procedure that we would do with anything else within the RID. And then finally, how do we integrate these data sources within the RID? Since we aren't creating any additional new layers that are part of the RID, it's simply using the intersection reduced data set and any of the crash data layers as you would within the RID currently. So you can use dynamic segmentation with any of those layers, and again, essentially use it as you would anything else in the RID currently available. The only difference is the CSV files. We're actually creating a new folder where we're going to store some of this extra information that doesn't integrate directly within the reduced data set. So in any new deliveries, you'll see a new folder called additional reduced data set info. Within that folder, we're going to store all these CSV files that a user could then use to replicate the results using their own defined threshold instead of the 250 and 150 feet that we use. And as well, we provide documentation for all the reduced data sets that we've created. This includes both the how-to guides that we're creating, as well as the user guide or the overall summary for this information. And then, as always, we will update all of our summary and metadata files that have the new fields that have been added to these reduced data sets, as well as a summary of what data is contained within all of the reduced data sets that we've created.
All right, thank you, Skylar. There are a couple of questions that we haven't addressed. I know, Skylar, you talked about the threshold distance. Did we address the Geometric Design Lab question about crashes that are within the threshold distance but identified by police as non-intersection related?
Yep. So that's the difference. So we've got our total intersection field that includes any of the intersections that are either within that 250 or 150 foot distance, and then we've got the intersection crashes, which it would be a subset of that total number of crashes. So those intersection crashes are ones that were coded as intersection related by the state DOT. So whether it's a police officer or whoever's submitting the form, so whatever that difference is would be any of the crashes that were not coded as being intersection related by the police officer.
Mike Griffith, how are you doing, Mike? Says, how many intersection crashes exist in the database? I know probably off top of our heads we don't. Can you give Mike a general number? Are we talking hundreds, thousands?
It will definitely be in the thousands or the tens of thousands. I don't have a precise number of how many of them are intersection related. The other nuance or caveat that I would put to this is we are using the intersection reduced data set, so that it would only be the intersections that were collected through the mobile data collection process. So this wouldn't be all intersections statewide.
So while we're answering questions, I'm opening the pod here for you to enter any additional reduced data sets that you would be interested in. Mike, we will follow up with you on in terms of the numbers. We should be able to have those numbers. Mike does have another question. What intersection safety research studies have been conducted thus far? Maybe a question for Federal Highway colleagues. Well, actually, Mike, interestingly, we're working on a white paper that talks about the research questions that could be answered using the reduced data set from the RID, where we kind of are, coming up with questions. We're also looking at existing research, and we're looking at the Turner Fairbank Pool Fund study on the SHARP2 NDS and RID in terms of some ideas of what research questions could be addressed using these reduced data sets specifically, and also the RID in general. Yusuf has a question. There is no count for PDO, property damage only, but that can be calculated as a difference of total and other injury counts. Correct.
No, it's not correct, because we tried to get the property damage only from all the crash data that was available. It wasn't consistent to get the total number of property damage only crashes, just purely based on the values that were being reported. So we decided not to include that field. You also couldn't do the total minus the injury counts, because again, we weren't able to get the total number of injury counts for possible and minor injuries. So for, I think, maybe 4 of the states, you technically could do that to get the total number of property damage onlys. But I think there were at least 2 states where we couldn't get the number of minor injury counts or the possible injury counts. So we ended up not including those values.
There is a question on if there are plans to incorporate involved and or vehicle data into the crash data into the future. And the answer right now is no, because one of the limitations we had is what the state DOTs were willing to share publicly in terms of the data set. And so we were able to get those crash data for the period of the SHARP2 NDS study, which is between 2010 and 2013, and we're able to incorporate that data into the RID because of the limited information that we are making available. I think if a researcher is interested in a special area, a study area, then they can definitely look at what we have identified as crashes in the RID and then go do further research within that DOT to look at, the vehicle information and also driver information.
And to note off that, we do have vehicle level information in Florida and Washington, but the other 4 states we don't have vehicle level information. And then Yusuf, I think it may be addressed in the documentation, but I'll go through it one more time and make sure if it's not included that we do explicitly mention the PDO crashes.
There is a question here in terms of a suggestion for additional reduced data set is the direction of the road the crashes have happened on. And that is definitely a limitation that Scholar talked about. We don't have that information in the original data set provided from the DOT. So you would have to be looking at the narrative of each crash to determine which side of the road the crash happened on. There might be, Zach seems to.
Well, the 2 states we have vehicle level data on, the initial direction of travel, I believe, is provided for both of those states. So that could be used, but it's not for the comprehensive RID because we do not have that unit level or vehicle level data for every state.
Thank you, Zach. Mike is asking, okay, he's clarifying his question. How many intersection crashes are in the NDS dataset only?
That's a
We will get those numbers to you, Mike, offline because I know we have this information, but we can't figure it out right now. That's Yusuf wanted me to also remind you. So we need to separate NDS crashes that happened with the experiment. So those were the instrumented vehicles. Those are not included in what we're providing. What we're providing are the police reported crashes in those 6 study sites for the study period. So if you're interested in crashes that occurred for the 2,000 vehicles that were instrumented, that is something that you would have to contact Miguel Perez and VTTI to be able to access that information. Any other questions? We have a little bit of time. I have a question for Zach, since Zach works a lot with crash data, whether it's Iowa or other state DOTs. Zach, how do you see this data set helpful for doing some research within the NDS or the Sharp 2 NDS, and even maybe outside the Sharp 2 NDS?
I think there are several opportunities available because we're dealing with 6 states. We have intersections, we have the configuration, we have the control. Some of this information is not readily available to crash level. So now we have that information integrated through some other information that we have in RID. You could also look at the lane configurations and things of that nature as well, whether there's turning lanes. So I think there's an opportunity to do some maybe CMF calculations through use of the data. And then one of the questions too, and what Skylar tried to account for, is what if intersection crashes are defined simply based on spatial proximity versus based on what is coded as an intersection crash. Now we know that there can be inconsistent encoding as intersection crash by law enforcement agencies, which is just understandable. But now we have many years of data across many states that there might be an opportunity to look into what is really should be considered an intersection crash. And so we have both that at an aggregate level, and then we could get down to the individual crash level if there's that level of interest as well. And then we know what type of intersections that we're dealing with. So you can kind of look at maybe different type of intersections and what would be a nice way from a population standpoint versus if you're doing like a traffic study to be able to kind of do some assessment that way.
So there's definitely a lot of potential, whether it's Sharp 2 related or outside of Sharp 2. Seems we're maintaining our attendees here, so I'll leave this open for another minute or so. We want to make sure that you're aware that we're using information from Esri, Digital Globe, GUI, iCube, multiple references here for to display the information that we shared with you. Again, I'll remind you that the PDF of the presentation is available for download. The recording of the webinar will be made available through the FHWA STAC, and we look forward to seeing you again in April when we talk about curve crashes, and back in June when we're talking about homogeneous segments. In the meantime, if you have any questions, please don't hesitate to contact us here at Iowa State or Yusuf at FHWA STAC. Thank you for joining us, and have a good afternoon.